Vai.
Okay, thank you, Marta, and good afternoon to everybody. So, as Marta just said, I will talk about another site that is excavated by UNIFE, which is the Ciota Ciara Cave. And we will talk in general about the site, so the different studies and investigation that have been made in these years about the archaeological and paleontological materials from the site, and then we will focus in particular on the lithic assemblage concerning the raw material supply areas, the technological aspects, and the use-wear analysis. And then we will see how a multidisciplinary study can contribute in a real understanding of the dynamics of frequentation of a Paleolithic site. Well, first of all, the Ciota Ciara Cave, we are in northwestern Italy, very close to the Alps, and we are in a region where the Ciota Ciara Cave represents the only Middle Paleolithic site that is known at today in this area. So the results of the study we are conducting there are very important, not only for the site itself, but also at a regional and also sub-regional scale. The cave is a still active karst cave. We are at the entrance of an alpine valley on an isolated relief, which is Monte Fenera. And we are at an altitude of about 670 meters at sea level. As Julie already said this morning, the cave was not frequented just during Middle Paleolithic, but also we are so good in archaeology that we also investigate a late Roman frequentation of this site. The importance of the Monte Fenera area in the archaeological research is known since the past century, but we can go very back in times, so we have some findings of paleontological remains also at the end of the 19th century, but it's just from the middle of the 19th century or the 20th century that we can talk really about archaeological researches with a scientific purpose. So as you can see, different institutional researchers worked in the cave during the years, but it's just from 2009 that University of Ferrara started its investigation in the cave, and that we have really a multidisciplinary and modern investigation of this area. So as I said, we started our excavation in 2009, and we concentrate our research in the atrial part, in the atrium of the cave, in an area of about 16 square meters. And when we reached the bedrock in almost all the excavation area, we moved inside the cave in 2018, and it is in this new area that we finally found, after 10 years of excavation, the first human remains that this morning Julie mentioned. The atrial part is so the only area where the studies about the archaeological and paleontological materials are complete. So from now on, I will speak about all the data I will present are from this area. Here, the stratigraphy we excavate is composed is about 2 meters thick and is composed by 4 main archaeological levels that presents more or less an horizontal disposition. And in particular, we have level 14, which would be very important for the studies about the Ciota Ciara Cave, because this level represents the most intense human frequentation of the cave. And so most of the data we have come from this archaeological layer. About chronology, the chronology of the site is a still open issue, since radiometric dating are still ongoing in Paris. When we start our work, we had a biochronological hypothesis about the chronology of the cave, which is here, so at about isotopic stage 5. Then we had data from radiometrics dating of level 14 that place the frequentation of the cave for this level at the end of the middle Pleistocene, and now we are dealing with the new radiometric datings to clarify this point and to have a final and definitive chronological collocation of the site. In the atrium of the cave, we completed also, Dr. Berto and colleagues completed the study of the micromammal assemblage, which was very important to gain a reconstruction of the paleo environment. And as you can see, we have between a stratigraphic unit level 13 and 14, so going from the most recent frequentation phase to the ancient one, we have a climate that became more arid and colder. And in the paleo environment, we see that while in stratigraphic unit 13, we have more, for the majority, a woodland environment. Going down in the stratigraphic sequence, we have an increase in rocky and open environments and open woodland. For what concerns paleontology, in all the archaeological layers, we have a predominance of carnivore remains, in particular Ursus speleus, because the cave was during winter was used by Ursus speleus for hibernation, while the presence of the herbivores is linked, this one that is linked to the human frequentation of the cave, because herbivores were taken inside the cave by humans for subsistence activities. And these herbivore remains have a great increase in level 14. And this is why I said before, the level 14 corresponds to the most intense frequentation of this site. An archaeological study was completed some years ago just on level 14, and it confirms the data about the data from paleontology, since we have in this level a great number of cut marks on herbivores remains, and in particular, the most interesting data is that we have cut marks also on Ursus speleus and Canis lupus remains. In particular, the traces on Ursus speleus belong both to fur extraction, but also to meat extraction. But we still don't know if the exploitation of Ursus speleus carcasses is a result of an active hunting to this animal or not. Probably not. So now we come to the lithic assemblage, which is a little bit particular, since you can see, the most exploited rock in this site is not flint, but is vein quartz. In all the archaeological levels, it represents almost half or more of the total lithic assemblage. And then we have the exploitation of another quite bad rock, which is spongolite. Is something like is a kind of chert, but is a very bad quality raw materials, since it's very difficult to control the results of the napping activity on this rock. And this is probably one of the reasons why vein quartz was preferred on spongolite. We can, among the raw materials, we can distinguish two main groups. One corresponds to the local rocks and the other one to the non-local rocks. Why can I say this? Because for vein quartz, spongolite, and these gray flint, we have in all the levels complete reduction sequences. For all the knapping methods, that means that these rocks were collected not very far from the sites. They were bring inside the cave as not exploited blocks, and then they were used to produce lithic tools. They were used inside the cave. Non-local rocks correspond to very good quality raw materials which are rhyolite and radiolarite. Rhyolite is an igneous rock, where radiolarite is part of the flint family. And they are present in the site just as the finished tools, many times retouched many times, and in the form of small or very small flakes belonging to the retouch phases of the tools. We start and complete the study of the supply areas of lithic raw materials, both for what concern local and non-local rocks. We applied a methodology which is quite conventional, in the sense that we start from the study of the geological data available, and we set up a program of fieldworks based on the GPS and the identification and GPS positioning of the outcrops, both primary and secondary deposit of these rocks. And we also collect several samples of rocks that were fundamental to be compared with the archaeological materials. Then we have also some lab analysis. First of all, the microscope observation of the archaeological materials, and then of the geological samples, and then we use XRF and SEM analysis to better characterize the raw materials and to compare the geological samples with the archaeological ones. A first study was completed by Giulia Berruto in 2011 for her master thesis, and was aimed to the identification of the primary outcrops of vein quartz. This was done through the identification on the archaeological materials of elements that are diagnostic for the identification of the primary outcrops, and I mean the identification of minerals and micas that are present on the surface of the vein quartz lithic artifacts. And then these micas and minerals were characterized through SEM analysis, and then compared with the geological samples collected all around the base of Monte Fenera, where these rocks outcrops vary with important quantity. The correspondence between, we observe a correspondence between some of the samples collected from three main areas all around Monte Fenera. So for sure, the vein quartz exploited at the Ciota Ciara Cave was from the surroundings of the site. But another problem we have to face about vein quartz, since on the archaeological on the lithic artifact, we observe very often the presence on their surface of neocortical surfaces. This indicates that vein quartz, as we expected, was not collected directly from the primary outcrops, but was collected in secondary deposits. Well, concerning chert, there are different methodologies to identify the possible secondary deposit from where the raw materials was collected. Concerning vein quartz, is more difficult because it is more resistant to alteration. So it's quite difficult to do this work, but always Giulia Berruto again try to apply a methodology based on the identification on some alteration on the vein quartz artifacts. Then she collected samples in different kind of secondary deposits, so rivers, streams, and fluvial terraces, for example. Then through the comparison, always using a stereo microscope between the archaeological neocortical surfaces and the geological samples collected, she came to the end of her studies with reliable hypotheses about the provisioning areas of vein quartz. And we observed slight differences in the secondary deposits that were used, because in the most recent phases of human frequentation, we have supply areas of vein quartz, mainly in fluvial terraces, always located at the base of Monte Venera, while in level 14 we have a predominance of supply areas of secondary deposits that correspond to river environment, probably directly from the Sesia River. All the other local rocks have been studied for what concern the supply areas, and through the same methodology. So all the Monte Venera area was a subject of field activities, and we were able to locate secondary deposit and primary outcrops of spongolite and also of flint. These outcrops are placed just a few hundred meters from the cave, and so one of the questions that arose was why do these Neanderthal groups of the Ciota Ciara Cave decided to exploit vein quartz that is which supply areas are more distant from the site, instead of exploiting just spongolite and flint, which are very close to the cave. Well, one of the answers is that spongolite, as I said before, spongolite is very hard to control the results of the netting activities on spongolite, and so probably they made a choice in this sense. For what concern the non-local rocks, this is one interesting part of this study, because we have to identify primary and secondary deposits that are located quite far from the Ciota Ciara Cave. In particular, radiolite comes from outcrops that are located at about 30-35 kilometers from the site, while rhyolite, here you can see Monte Venera on the background. The rhyolite was collected at a distance of about 2 kilometers from the site in the Sessera River. The comparison between the geological samples we collected in these areas and the archaeological materials confirmed through the XRF analysis the consistencies between the archaeological tools we found at the Ciota Ciara Cave and the geological samples we collected. And so for the first time for this area of the Italian peninsula, we can make a reliable reconstruction of the supply areas of lithic raw materials, which has another important consequence, because here we can say that obviously the cave was not inhabited during all along the year. As I said before, during winter, Ursus spereus was in the cave for hibernation, so humans do not frequent the cave during winter. So where does the Neanderthal groups go during this season? Probably they move towards east, in the direction from where the radiolite outcrops. From a technological point of view, the predominance of vein quartz in the lithic assemblage is quite interesting, because allow us to make to face some interesting problems. The first one was to identify the different reduction sequences on these particular raw materials, and then we try to understand how the characteristic of vein quartz in terms of its response to napping, its tendency to break, and so on, affect the reduction sequences, and which adaptation were put into action by the Neanderthals of the Ciota Ciara to the characteristic of these raw materials. If we look at the napping methods, we see a clear predominance of the opportunistic and multidirectional reduction strategies, but we also see that the discoid and Levallois methods are very well attested. Another elements that we can highlight is the quite high number, important number of debris, which is a consequence of the tendency of quartz to break during napping activities. The particular characteristic of vein quartz made necessary to refer to already published experimental works focusing on these particular raw materials, since on vein quartz for its structure is quite difficult to identify the napping scars on flakes and on cores, and also before starting the study of a vein quartz assemblage is very important to take into consideration its tendency to break during napping activity and to see how vein quartz breaks during napping activities. So starting from this work, we have a very important tool to understand and to correctly interpret the data we had from the archaeological record. The opportunistic technology, as we saw, is the most attested in the site. We have, in general, for all the raw materials, we have short reduction strategies. So it means that the natural blocks were exploited to obtain a very limited number of products, and the cores are usually abandoned before their exhaustion. We have unipolar opportunistic reduction sequences that are far dominant in the assemblage, while the multidirectional reduction strategies are a minority in the assemblage. We also see the preferential use of natural striking platform. It means neocortical surfaces or flat surfaces that are naturally present on the cores. Another observation that we can make about the opportunistic technology concerns spongolite, which is here. Spongolite was collected in the form of slabs, little slabs, and they are always exploited according to their thickness. So in a transversal way with regards to the natural cleavage plan of the blocks. This could be an adaptation to the raw material characteristic which allow the napper to avoid fractures of the flakes. For Levallois technology, we see clearly and better the adaptation to the raw material, since, well, as you know, for a Levallois debitage, we have to respect some criteria in the morphology of the core, and we usually have phases of core configuration that could be more or less important, but there are always present and that are part of the definition of the Levallois method itself. At the Ciota Ciara Cave, we observe some particular characteristic in Levallois reduction strategies. First of all, we have two Levallois methods attested in the site, which are the preferential Levallois and the recurrent centripetal Levallois. But again, we have short reduction strategies, so it means that each core is used just for the production, one phase of Levallois production. Then the core is discarded, even if another production phase could have been achieved. And also we have the use, very frequent, of natural striking platform. This means that the Neanderthal of the Ciota Ciara Cave choose vein quartz pebbles and blocks that already had on their surfaces the suitable convexities for a level 1 exploitation. We observe just sometimes and more often on the preferential level 1 course the preparation of the flaking surface, but the streaking platform is is never prepared. The discoid technology, for the discoid technology, we can make similar observations. We have two discoid modalities attested in the site, which are the unifacial and bifacial modality. Here, as I said, for the level 1 method, we don't have any core configuration. So the discoid exploitation starts directly from the natural surfaces of the core. So it is fundamental to choose to proceed in this way is fundamental to choose natural blocks with suitable convexities. So what seems clear from the technological study of the lithic assemblage of the Ciota Ciara Cave is the strict correlation between the initial morphology of the core and the choice of the knapping method. What does it mean? For example, vein quartz was available in secondary deposit as rounded pebbles or as polygonal blocks. The rounded pebbles were used for different reduction strategies: Valois in the recurrent centripetal and preferential modalities, discoid, and opportunistic debitage, while the vein quartz polygonal blocks were used exclusively for opportunistic exploitation. No discoid and no level 1 debitage are used on this kind of natural blocks. The same as we said for spongolite, slabs are used for unipolar, for opportunistic debitage, while just small polygonal blocks with convexities suitable for discoid or for level 1 debitage are used for this kind of lithic production. So the raw materials affected the production of lithic tools at the Ciota Ciara Cave very strongly, and in different way in the choose of the knapping method and in the strategies in which these knapping methods were put into action for the production of lithic tools. The last but not least study we made on the lithic assemblage of the atrial part of the Ciota Ciara Cave is the use-wear analysis. It was completed on all the raw materials and on the entire lithic assemblage. So we have data from all the levels, level 13, 14, and 15, and for all the rocks that were exploited. The first thing for the use-wear analysis was the experimental activity. So we produced some lithic tools in vein quartz, spongolite, and flint to see how they work and to perform butchering activities, skin working, bone working, and the processing of antler. We have made some observation during this experimental activity, in particular regarding the efficiency of the different raw materials. So we observed that, for example, vein quartz is very efficient in butchering and other activities, but its edges tend to break very, very quickly. Spongolite, on the other hand, spongolite is not efficient at all. So this could be one of the reasons of the choice of vein quartz as the most exploited rock in the site. Then, after the experimental activity, the experimental tools and the archaeological lithics were first selected at the naked eye. So just complete or incomplete flakes with a good state of preservation, especially for what concern the functional edges, were selected for these studies. And then all the selected artifacts were observed at the stereo microscope and then at the metallographic microscope. The difference between these two approaches is that at the stereo microscope, so what is called the low power approach, you can observe macro traces. So it means edge breakages, fractures, and so on, while at the high power approach, you can observe the micro traces like polishes and other elements that are useful for the identification of the material worked. With the low power approach, you just can identify the direction of the movement, so if it's a longitudinal or a transversal movement, or and the hardness of the material worked. The result, we will see that they show some differences between the different archaeological levels, because, for example, in level 13, we observe on quartz, spongolite, and flint, we observe the predominant use of the lithic tools for woodworking activities. Yes, we have also butchering activities, but most of the tools show the processing of vegetal resources, in particular wood. While in level 14, we have very different activities attested by the useware analysis. We have a clear predominance of butchering activities. Then we have woodworking, fresh-eyed working, bone working, and so on. In particular, the fresh-eyed working attest the presence of the practice of activities that request a long time to be completed. So this is another data in favor of a longer or a most intense and longer frequentation of the cave during the deposition of level 14. A particular work about level 14 is the one on radiolarite and rhyolite radar tools, which was completed this last year by Paola Fuselli during her master thesis. So, as we said before, these rocks are present in the site just as retouch tools and as small flakes belonging to the rejuvenation of the margins of the edges of the tools. And it was interesting to see if these tools were used for particular activities or not. The result of the study showed that they were multifunctional tools, and each of them has more than one zone of use. So it means that they were intensively used, and the fact that their margins, their edges were retouched many times, it means that their use was very, very intense before they were discarded. One particular thing is about the radiolarite tools, that since a very high number of them show the use of these tools as for longitudinal action. In level 15, we come back to the same situation of level 13. So we have less activities attested and the predominance of butchering and woodworking activities. So the multidisciplinary study conducted on the lithic assemblage of the Ciota Ciara Cave show us different things. So we have an intense exploitation of raw materials that are collected very close to the site, in particular vein quartz and spongolite, but also we have a seasonal mobility directed towards east, during which we have the collection of raw materials of better quality of better quality that are used, like radiolarite, that were used for the production of tools that are multifunctional tools that were transported from east to the Ciota Ciara Cave during these seasonal movements, and the multifunctionality of these tools and their characteristics could suggest us that they were part of what Kuhn defined as personal toolkits, probably. So a set of tools that each man brings with itself during his mobility for subsistence activity, and that usually are made of rocks, of raw materials that are better than the ones he could have found at the end of his trip. For what concerns the technological behavior, we see that it was constant all along the sequence, and it was very, very opportunistic. So in what sense? Not just in the sense that we have opportunistic reduction strategies as main strategies for the production of tools, but opportunistic in the sense that they exploited the local raw materials in the most efficient way that was consented by the raw material characteristic and the geometry of the natural blocks that were available in the area. And in general, we observe a very low technological investment in the production of lithic tools, also when more complex and predetermined reduction strategies are used. For example, the level 1 and the discoid method. If we put all together the data we had from the micromammal study, the paleontological data, the technological study, and the archaeozoological analysis, we can reconstruct more or less the dynamics of site frequentation during Middle Paleolithic at the Ciota Ciara Cave, and we can also make some correlation with the kind of occupation and the local environment. So in going from the most ancient to the most recent frequentation, we pass from an open woodland environment to forest environments with short occupation that became longer during the deposition on level 14, and again they became short in the most recent phase. But in all these phases, one thing remains constant, and is the production inside the site of the lithic tools, with the presence of imported elements, so the rhyolite and radiolarite objects, that are an important, very important data to understand the mobility and the direction of the mobility of these groups all along the northern Italy. Thank you.
Thank you very much, Sara.
If you have questions.